So yeah, so basically we have 3 more chapters to go, which is awesome, right? So carboxylic acid derivatives is what we'll be talking about now in this chapter, and those are very huge class of compounds. But the good thing about that is the chemistry is the same. The chemistry they undergo is the same. So if you know the mechanism for one, all you need to remember for the others are the reagents, because the mechanism is going to be the same. Okay? So please pay attention to the mechanism. What are carboxylic acid derivatives? Well, if you have a carboxylic acid, that carboxylic acid has OH functional group connected to the acyl group. Remember, we call this the acyl group. So that's a carboxylic acid. So basically, you can change or manipulate that OH functional group to other functional groups. Okay? So when you change that OH to any other functional groups other than OH, it becomes a derivative of the carboxylic acid. Okay? So when you have halogens, those are referred to as acid halides. When you have a carboxylate, bless you, when you have a carboxylate connected to the acyl group, those are referred to as acid anhydride. When you have an alkoxide connected to the acyl group, those are referred to as ester. Okay? Sorry. Nice and warm. All right? And when you have, bless you, an amino group, those are referred to as amide. Remember the question you had, Tiana, about amide? So these are amide. They are different from amine, right? So when you have a thiolate, so thiolate is like an ester, but the difference is the oxygen has been replaced with sulfur. Okay? So that's why they are referred to as thioester. And when you have a phosphate group, you just call them acyl phosphate. And like I said, the reaction that they undergo is the same, and it's referred to as nucleophilic acyl substitution reaction. Nucleophilic acyl substitution reaction. So generally, if you have a nucleophile, the nucleophile can attack the carbonyl carbon, breaking the carbonyl double bonds, which is going to reform, because you have a good leaving group in the you have a good leaving group connected to the acyl group, which is Y, and that leaving group is going to be expelled. So now you have a nucleophile connected to the acyl group, and the leaving group is off. So that's the general reaction that they will be undergoing. Okay? So now we're going to try to name each of these derivatives. Okay, we're going to name each of these derivatives. Let's start with acid halide. If you want to name acid halide, the first thing you want to do is to identify the acyl group that is connected to the halogen, and you get the name of the acyl group from the corresponding carboxylic acid. So all you need to do is to change the ic acid that ends the corresponding carboxylic acid with -il. Okay? But if it's a carboxylic acid, then you change the carboxylic acid ending of that compound to carbonyl. So here are examples. If you look at this structure that we have here, it came from, because if you remember, the only thing we're changing is the OH functional group. So it came from this compound, right? That is the corresponding carboxylic acid. Okay? And that carboxylic acid has 2 carbons, right? So if you want to use the systematic names, you would name it, because it's 2 carbons, it's like from ethane, so it's ethanoic acid, right? That's the systematic name, will be ethanoic acid. Let's put it there. This one is ethanoic acid. Okay? But it also has a common name of acetic acid. Alright? So, if you are using the systematic name for this compound, which is ethanoic acid, the rule says you're going to change this ic acid altogether to -il. Okay? So that means the name, the systematic name for this guy will be ethanoyl chloride. Okay? That will be the systematic name. But if you want to get the name from the common name, which is acetic acid, it will now be acetyl chloride. Okay? So depending on what you want to use. Now, the second structure here came from this carboxylic acid. Okay? And what is that? Benzoic. That benzoic acid, right? So it's benzoic acid. Alright? The rule says you're going to change the ic acid to -il. Excuse me. Okay? So that would be what? Benzoyl bromide. If you look at the last one here, it came from this carboxylic acid, and in naming that carboxylic acid, you call it cyclohexane carboxylic acid, correct? Because this is a cyclohexane, and the carboxylic acid functional group is coming off of that, so this is cyclohexane carboxylic acid. Bless you. So the rule says when you have such name, you're going to change the carboxylic acid ending to carbonyl. Alright? It says you change that to carbonyl. Bless you. Oh, what's going on? Is it the heat? Alright. So you change it to carbonyl. So we're going to get cyclohexane carbonyl and then the halogen fluoride. All right. Okay. All right. So let's move on. Yeah. Oh, okay.
Is that three separate words, or is it cyclohexane carbonyl?
Oh no. So the cyclohexane carbonyl. Well, you can write them together. Okay. So, but the chloride will be separate. Yeah. All right. So let's go to the next one. You guys in the back can see the board, right? Or is it too bright? Okay, from the back? Okay. All right. Acid anhydride. Anhydride. Now, there are two types of acid anhydride. You can have a symmetrical acid anhydride, meaning the two acyl groups are the same, or you can have asymmetrical, non-symmetrical acid anhydride, meaning the one acyl group will be different from the other. Okay? So if you're trying to name an acid anhydride which is symmetrical, all you need to do is to replace the word acid that ends the corresponding acid with anhydride. Okay? So if you look at this, okay, you can either call this acetic. This came from acetic acid. Oh, acetic acid. Or if you want to use the systematic name, ethanoic acid, right? So it says we should change the acid ending to anhydride. So all you need to do is to replace this with an anhydride. So this is going to be acetic anhydride. Okay, so that will be acetic anhydride. This one here came from benzoic acid. Okay, and you can see that this is symmetrical. That's what you have on the other side. So this is going to be benzoic anhydride. Okay. Now this one here, it's a little bit tricky, and you have to just remember the name. Remember, we have NBS. What is that called? N-bromosuccinimide, remember? Okay, so that's N-bromosuccinimide, NBS. You've used it a lot, right, for bromination. Okay, so it's called N-bromosuccinimide because you have nitrogen and you have bromo. Okay, so that's why it's referred to as N-bromosuccinimide. So the bromine is on the nitrogen, and the structure itself is succinimide. Okay, succinimide because it's an amide. All right, now it's an anhydride. Okay, so we're just going to borrow that name, succinic anhydride. So you just have to remember that. Okay, succinic anhydride. All right, if you have asymmetrical, non-symmetrical anhydride. You cite the acid in alphabetical order and change the acid ending to anhydride. Okay? So you can call this acetate if you want to, or acetic, from acetic acid. Let's say from acetic acid. And this has how many carbons? 1, 2, 3. So it's from propanoic acid. So A comes before P, therefore the name for this would be acetic propanoic anhydride. Okay. Now for this, you have acetic, and then over here, benzoic, right? So therefore the name is going to be acetic benzoic anhydride. Now, instead of using acetic, if you want to call this ethanoic, which is the systematic name, what will the name of the anhydride be? Yeah, you have to switch it. Very good. So this is now going to be benzoic ethanoic anhydride. Okay, very good. So now let's go to amide. Some people call it amide, some people call it amide. Whichever one you choose. It's spelled A-M-I-D-E. Okay. So to name an amide, you first have to think about whether it's a primary amide, meaning it has NH2, and that NH2 has nothing, no alkyl group on it other than the acyl group, right? So if you're dealing with that, you just replace the name of the, again we said they are derivatives of carboxylic acid, so you change that oic acid that ends the corresponding carboxylic acid's name, or if it is ic acid, depending on what that corresponding carboxylic acid is, you change those to amide or amide. All right. If it's a carboxylic acid from cyclohexane or cycloalkane, you change the carboxylic acid ending to carboxamide. Okay, change it to carboxamide. So let's see these examples. This is from acetic, so it becomes what? Acetamide. Okay, let's break it down. Okay, because this is from acetic acid, and the rule says we should change this ic acid to amide. So we change this ic acid to amide. So that's why it becomes acetamide. How about this? 1, 2, 3, 4, 5, 6. Okay, so what would that be? Hexanamide or hexanamide. Okay, because it's from, it has 6 carbon, so it's X hexanoic acid, but we change the ic acid to amide, so it's hexanamide. Is it making any sense? Okay. Alright, so what about if you want to name this? This came from the corresponding, so this is from cyclopentane carboxylic acid, right? So it came from this guy, and the rule says we should change the carboxylic acid ending to carboxamide, right? So this is going to be cyclopentane. Oh, my pen is carboxamide. Make sense? Okay. All right. But if you have the amide group, if you have the nitrogen, instead of having NH2, if you have an alkyl group on that nitrogen, okay, if you have an alkyl group on that nitrogen, you have to identify those alkyl groups or whatever the substituent is that's on nitrogen, and you put the letter N in front of those substituents to indicate that they are sitting on the nitrogen. Okay? Because if you don't put the N, it will be like that alkyl group is from the chain, right? Okay, so that's why you have to put the N. So let's look at an example. Okay? So here you have, this is skeletal structure, so there's a CH3, correct? Okay? And this is from acetic acid. Okay? So because there's a methyl group on the nitrogen, we're going to say N-methyl, and then we put the acetamide. Okay? Because if you, well, yeah. If you say methyl acetamide, although there's not going to be methyl acetamide, a methyl acetamide would be like propanamide, right? But if you say methyl acetamide, that would look like that methyl group is coming off of the acetic group, right? Okay? So that's why you have to put the N. You guys understand what I'm saying, right? So if you name it as N-acetamide, this would be like, this is an acetamide, right? If you don't put the N and you just say methyl acetamide, oh, you guys cannot see that, right? Okay. So this is acetamide. If you don't put N in that name and you just say methyl acetamide, it will be like a methyl group is coming off of here, which is basically what? Propanamide. Right? So that's why you have to put the N. Okay? You had a question? Oh, okay. Alright. So, what about the second one? So you have an ethyl group here and an ethyl group there, both sitting on the nitrogen. So it's going to be N, comma N, because there are two. Diethyl. Now, because this is cyclohexane, it becomes cyclohexane. We're going to continue down here. Carboxamide. give another example here. Let's say we have this from the acetic acid. So we have methyl group here, and we have ethyl group here. Okay. If it were two methyl groups, you say NN dimethyl acetamide, right? But now you have a methyl and you have an ethyl. Okay. So to name that, you're going to identify each functional group, that each substituent that you have there. I'm going to write the name down up here. Okay. So you list them in alphabetical order. E comes before M. So you're going to say N, ethyl, N, methyl, then acetamide. So that is saying that that ethyl is on nitrogen and that methyl is on nitrogen. You're not going to say NN ethyl methyl. Okay? You only use NN if they are similar, and then you put di in front of that alkyl group. Or well, it's cannot be tri, it can only be that. Make sense? Any question? Okay. Alright, ester. To name ester, you change the ic acid to A because they're edible. I'm just kidding. Well, most of them are actually, because that's you make in food industry, a lot of all these flavors are esters. Like, I don't know, did non-chem majors, did you synthesize esters? No, you did not. Well, the chem major did in the lab. So basically, the whole essence is to synthesize compounds that will smell like different fruits. So you have compound that smells like apple, peach, banana, and so on and so forth. So it was very nice smelling in the lab. The only thing is, like, you couldn't taste it, right? Because it's not very pure. Okay? So yeah, so I guess when they were thinking about that, they just thought, well, since it's edible, let's just say A, right? So that's a good way to remember esters. Okay, so you change the ic acid to A. Okay, A. All right. So what do? The first thing you do is to identify the alkyl group that you have on the oxygen. Okay. So this is an ethyl, and then this becomes the parent chain. So because you have two carbon, you can say ethanoate, or you can say acetate. Acetate is the common name, right? But the systematic name for this is going to be what? Ethyl ethanoate. Why is it ethyl ethanoate? Because it says we should change. So this is from, we are using systematic name. This is from ethanoic acid, and it's the rule says we should change that ic, just the ic acid without the O, ic acid to 8. Okay, so that's why you can call that ethyl ethanoate. Now this is a common name, dimethyl malonate, because it has methyl group here and another methyl group there. So that's why you have the dimethyl malonate is a common name. So you have to remember that. But if you want to do systematic name, which is the IUPAC, you're going to look at how many carbons you have here, which is 3. So it's from a carboxylic acid with 3 carbon chain, which is propane, right? So, but it will have 2 carboxylic acid functional group at the end. So that would have been propane dioic acid, right? Let's try to put that up here. So this is the corresponding acid from which it came. So this would have been propane dioic acid. Okay, but the rule says we should change the ic acid alone to A, right? So that means this will be dimethyl, because you have two methyl groups on it, propane dioate. Okay. All right. And then for carboxylic acid, you change the carboxylic acid end into carboxylate. Okay. So that's why this is a third butyl. So that's the third butyl group. The butyl cyclohexane carboxylate. Make sense? All right. Good. Wow. Naming just for 1 hour. That's awesome. Okay. Thioesters. If you want to name thioesters, you name them like their corresponding esters. Okay, which we just did, the esters. But to indicate the changes that you have in the structure, the substitution you have in the structure, the O has been substituted with S, you're going to put prefix thio to a carboxylate that came from a common name. Okay? You put thio to a carboxylate, a prefix thio to the carboxylate that came from a common name. Okay? But if it's a systematic name, you're going to change the O8 to carboxylate. Or sorry, you're going to change the O8 or the carboxylate to thio8 or carbo-thio8. Okay? So, let's look at this example here. This came from methyl ethanoate, or you can say methyl acetate, because methyl acetate, because the acetate is a common name, that's not a systematic name. You're going to name the corresponding thioester by putting this thio at the beginning of the acetate, because it's a systematic name. Alright? But if you want to use the, sorry, because it's a common name. But if you want to use the systematic name, okay, if you want to use the systematic name, this will be from methyl ethanoate. So that's the systematic name. The rule says you're going to add thio before the O8. Okay? Right, so this will now be methyl ethane thioate. Okay. Why did we spell it out as methane? Because you have N and T consonants being together will not be, so we are putting the E back there. Okay. And then you have the other examples, ethyl butane thioate. Why is it butane? 1, 2, 3, 4 carbon chain. That's why it's butane. Alright. And then if you have a carbocycle, like cyclohexane, cyclopentane, cyclobutane, cyclo whatever. So that becomes cycloalkane carbothioate. Okay. So how do we name this? Because you have an ethyl group here, this would be ethyl, because that's an ethyl group. This is a cyclopentane, and it comes from a carboxylate. So we change the carboxylate to carbothioate. So the thiol is going before the A. So they are trying to let you know that there is a sulfur in what you're trying to eat. So it's no longer your ester, it's a sulfur. Okay? Alright. So the last of the group here is phosphates. Okay? So to name the phosphates, you identify the acyl group, and then you just add the word phosphate at the end. Okay. The acyl group for these is so it's from benzoic acid, right? Right? So it would be Ben phosphate. Okay? Now, the second rule is if you have, let's say, as we have this, oh, the pen is dying out. Finally, we tried. Oh wow. Right on the last. So let's say you have a methyl group on this guy. We tried. So let's say you have another group, another alkyl group on one of this oxygen. Okay. Because this can be alkylated. Okay. You've heard about adenosine triphosphate, adenosine diphosphate, and so on and so forth, right? So you get to talk about that in biology and biochemistry. So this can be alkylated. If you throw in alkyl halide onto this, it can alkylate that, right? So if you have an alkyl group on this oxygen, the rule says you want to identify it and add that alkyl group's name after the acyl group's name before you put the phosphate. So that means this alkyl group should be between your acyl group and your phosphate. All right? So this would be the acyl group here is a benzoyl. And you have a methyl, and then you have the phosphate. Okay? All right, so we're going to stop there today. Do you guys have any questions?
So I noticed that on OWL, the homework for chapter 39 is due on Sunday.
What Sunday?
This Sunday, 27th.
Oh, no, well, I feel like
Okay, that's I wanted to
I always monitor that, right? So we didn't know that we're going to have the so.
Yeah, okay.